Good afternoon, children. Welcome to today's class. As we were discussing the type of chemical reactions, and we have already discussed decomposition reaction. We have already discussed uh, the type of reactions. Okay, and the first one was combination reaction or synthesis reaction. There, one thing we have discussed, one experiment we have done, that is between the the topic is type of reaction, types of chemical reactions. There are mainly four types. The first one, which was combination reaction, this already we have discussed in our previous class. Okay, so there was one example between the reaction between ammonia and HCl, where we did this reaction in a glass tube. Okay, and in this tube we have taken two cotton balls. One is soaked with HCl, hydrogen chloride, and another, this is HCl, cotton ball soaked in HCl, and this one here, the same manner we have taken the cotton ball soaked in ammonia. Okay, now when these two will react, we are going to get ammonium chloride. Okay, this ammonium chloride will give a white dense fume, and that we can get as a white ring here. Okay, this is white ring of ammonium chloride. Now the question is, why this white ring will form near this end, the end of end of HCl. Okay, so about this only I was discussing in the live class. So what is the reason? For this we have to know the molecular weight of ammonia and HCl. See, if we calculate ammonia, the molecular weight will be, for nitrogen it is 14, and for 3 hydrogens it is 3 into 1. So that means it is 17 AMU. This is the molecular weight of ammonia. Okay, molecular weight. The same for HCl will be, if we calculate hydrogen 1 and chlorine is 35.5. So total this is 36.5 AMU. Okay, this is the molecular weight of HCl. Now here we can see, as ammonia is lighter than hydrogen chloride, so that rate of diffusion of ammonia will be faster or more than HCl. Okay, that means the rate of diffusion faster in ammonia. Okay, as molecular weight, as ammonia is lighter than HCl. That's why we are going to get the white ring near this end. Okay, near this end of HCl. As ammonia will travel more than HCl, so the white ring here, these two will get together. These two, HCl and ammonia, will combine together at this point, and we are getting this ammonium chloride. So this was the reason behind this. Okay, now the second type of reaction which we are going to discuss today, that is decomposition reaction. This is just opposite to this combination reaction or synthesis reaction. Decomposition, by the name only you can understand, a substance will decompose or break down to produce two or more substances. Okay, it may be element, it may be compound, or it may be both. So now we are going to discuss decomposition reaction. Okay, so here AB, this is the substance, this is the compound. So this will decompose. We can use heat or any other method also, or generally if we use heat, if we apply heat on the substance, then it will decompose to produce A and B. These are the products. Okay, so this is the substance which is going to decompose, and after decomposing this, after the reaction, we are getting A and B. Okay, these two products. So such reactions, example of this kind of decomposition reaction can be given as mercuric oxide, CHGO. If we heat this, okay, these are the examples. Examples of decomposition reaction. Mercuric oxide, if we heat this, we are going to get mercury and oxygen. Okay, this reaction is not balanced, you can see this. So to balance it, we need to take 2 mercuric oxide, then 2 Hg will be produced and oxygen. Okay, so here you can see from a compound we are getting 2 elements. Mercury is an element, oxygen is also an element. Okay, so 2 elements we are getting here. Another reaction, potassium nitrate, KNO3. Okay, if we heat this, this is the sign of heat, delta we can call it. So from 2 potassium nitrate we get potassium nitrite, 2NO2 and oxygen. Okay, so 2 KNO2 plus oxygen. Here this is a compound and this is an element. So from a compound we can get a compound as well as an element. Okay, and in the first reaction we have got 2 elements, mercury and oxygen, from a compound. Next, we can use electric current also. Okay, the reaction between the electrolysis reaction of water, if we pass electricity through water, through acidified water, then we are going to get hydrogen and oxygen. Okay, so water will decompose to produce hydrogen and oxygen in this reaction. So electricity is also an this is also can be used to get the decomposition reaction, like this heat. Okay, it's a condition we can say. So heat or electricity both can be used, or this can be used as an for this decomposition reaction. So for water we need to balance it, 2H2O. So 2H2, 2 hydrogen and 1 oxygen. Okay, so this is some more examples of decomposition reactions are there. Generally, as a condition of decomposition reaction, we use heat. So by heating we can get this. Okay, so see, calcium carbonate, okay, marble or calcium carbonate, this by applying heat, this will decompose to produce calcium oxide, CaO, and carbon dioxide. Okay, here we are getting 2 compound. Okay, From a compound we are getting to simpler compound by this decomposition reaction. For potassium chlorate, this is a well-known reaction. When heat is used as a condition, for most of the reaction we are using heat for the decomposition reaction. So these can be called as thermal decomposition also. As we are using heat, so thermal decomposition also can be called. Okay, so from potassium chlorate, here again we are applying heat. It will decompose to produce potassium chlorate, KCl, and oxygen. Okay, I am not balancing this. So here also we are using heat for this reaction. Copper carbonate, cupric carbonate. Here again we are using heat to produce cupric oxide and carbon dioxide. Okay, this is hydrogen peroxide, H2O2. Okay, this again on heating it will decompose to produce water and oxygen. Okay, so 2H2O2, we need 2H2O plus O2. Copper hydroxide, again on heating, this will produce copper oxide and water. So these are the examples of decomposition reaction. Sorry. Now let us do an experiment. This reaction is also we have done in the previous portion, that is the heating of lead nitrate. Okay, so here many observations we can see, we can get many changes here. So what we are going to do, in a test tube we will be taking a dry test tube like this, and we will be holding this test tube through the test tube holder. Okay, so this is a test tube holder. So we are going to take this dry test tube, and in this here we will be taking lead nitrate, PbNO3 whole 2. Okay, so the reaction is, if we heat lead nitrate PbNO3 whole 2, then on heating, lead nitrate is white crystalline substance. So when we are going to heat this, we will get lead oxide, which is yellow. Okay, yellow residue, along with we are going to get a reddish brown vapor of nitrogen dioxide. Reddish brown vapor of nitrogen dioxide along with oxygen. Okay, so here oxygen gas will also evolve, but as nitrogen dioxide, it's having a strong color, reddish brown color, so it will mask the oxygen gas. So here the observations are yellow residue of lead oxide. This will be red or reddish or brownish when it is in hot condition, but when it will get cooled down, we will get the yellow color of lead oxide. Okay, and along with this reddish brown vapor of nitrogen dioxide will be observed along with oxygen gas. So this is the chemical reaction here. So how we are going to perform this? In a dry test tube, we are taking this lead nitrate and we will heat this. Okay, so in this manner we will not heat, we will keep it little bit inclined, near about at 45-degree angle. Okay, on this Bunsen burner. Okay, and we are going to heat this. So on heating, we will be first we will see this this lead nitrate, the white lead nitrate, that will melt a kind of, and then it will become reddish or brownish, and then after strong heating we will see this reddish brown vapor, and then if we take it out from this heat, then the yellow lead oxide will be observed at this bottom of the test tube. So this was the decomposition reaction, which easily we can do uh, in the lab. We can do, or if this lead nitrate is available, then you can do this at your home also. But nitrogen dioxide, this is it's not good for our health, so you have to be very careful when you're if you're performing this at your home. Okay, so this was all for today. You just go through these reactions, go through this decomposition reactions are very easy. Only just from AB we are getting A and B. Okay, like two or more substances, two or more simplified substances we are getting in this reaction. So this was there, and here only I am ending our today's class. You just keep on reading and revise it. Have a good day. Thank you.